So we have a problem wherein the radius of Mars is given to us as a value of 3.37 times 10 to the 6 meters, and its mass is also given to us as a value of 6.42 times 10 to the 23 kilograms. We are asked to find the time, as in how long it will take a rock dropped from 2 meters above the surface of Mars to reach the ground. So essentially, first and foremost, what we have to do is find out the acceleration due to gravity on Mars in order to find that time value for the rock to reach the ground. So how do we go about doing that? I just know that the acceleration due to gravity, or the gravity on Mars, is 38% that of Earth. So I can just multiply 0.38 times 9.81, which is the acceleration due to gravity on Earth, and arrive at a value of 3.77 meters per second square.
Power on, pairing.
Shut up. So let's find out how to arrive at that value of 3.77 meters per second square, which is the acceleration due to gravity on Mars. So let's say this is Mars, and we know its weight and we know its radius, and there's a rock that's here, let's assume that's 2 meters above the surface, being dropped on the surface of Mars. So we know that the force of gravity acting on an object is equal to, in this case, the gravitational constant times the mass of the planet, so we'll say the mass of Mars, times the mass of the rock, because we're dealing with this specific case, times the radius of the planet. And we'll assume that 2 meters is kind of like negligible in this case because the radius is so much larger than 2 meters. So we'll just round it off the radius to 3.37 times 10 to the 6 meters square, which is the radius. Nothing but the radius. Sorry, I substituted this early. So we know the force in this case acting on the rock is nothing but its weight on Mars. So its weight is nothing but the acceleration due to gravity on Mars times its mass. So we'll say the force is equal to the mass of the rock times the acceleration due to gravity on Mars. And we'll keep this side of the equation the same. So we have our gravitational constant, we have the mass of Mars, we have the mass of the rock, and we have our radius, which we just substituted early, as 3.37 times 10 to the 6 meters squared. So notice that the mass of the rock on both sides cancel, and we can find our acceleration due to gravity on Mars now, because we know our gravitational constant is 6.67 times 10 to the 11. We know our mass on Mars is 6.2 times 10 to the 23, and we know our radius as 3.37 times 10 to the 6 meters per second, meters square. So you can punch this into your calculator. I've already done that and arrived at the acceleration due to gravity on Mars as 3.77 meters per second square. Okay. So now we know our acceleration due to gravity. Now that we've found our acceleration due to gravity on Mars, we have to find the time it takes for the rock on Mars to reach the ground if it has been dropped from a distance or a height of 2 meters. So we know our initial velocity is 0, and we don't know our final velocity, but that's okay. We know our initial distance, or final distance, final position as 0 because it's on the surface of the ground, and we know our initial position as 2 meters because that's the height. So using our position formula, recall position formula is final position equals to initial position plus initial velocity times change in time plus half the acceleration due to gravity, or the acceleration, but in this case it's acceleration due to gravity, times change in time the whole square. So we know our final position is 0 meters, our initial position is the height, 2 meters, our initial velocity is 0, so this term would be 0 totally, a big 0, plus half the acceleration due to gravity. In this case, the acceleration due to gravity will be negative because it's acting on the rock is moving in a negative direction, it's moving downward. So we'll do negative, we found that out as 3.77 times change in time the whole square. We're looking for this value, the change in time. So just doing some algebra, we can bring the 2 to this side of the equation, so it'll be negative 2 is equals to half times negative 3.77 times change in time the whole square. So this would be negative 4 over negative 3.77 square root would be equal to our change in time. This is just algebra. So we'll do that. That's the time it takes for the rock to be dropped from a height of 2 meters to the surface of Mars, with our acceleration due to gravity on Mars as 3.77 meters per second square, which is nothing but 38% of the gravity on Earth.